Once you collected your data, maybe the first thing that you want to look at when exploring your data set is look at the measure of the central tendency. So what is a measure of central tendency? By the definitions, it is a value that represents a typical or a central entry of a data set or a distribution. So these values indicate where most values in the distributions fall, and also is referred to the central locations of the distributions or of a data set. So there are three most common used measures of central tendency. They are the mean, the median, and the mode. And depending on your data's characteristics, you will pick a typical measure for the central tendency. For an example, if your data are quantitative, usually you would use the mean or the median for the central tendency. If your data is qualitative, then you would use the mode for your central tendency. So for quantitative data, how can you find the mean of your data? So the mean, by the definition, it is the sum of all the data entries and divided by the number of entry. The sum of all data entries divided by the number of entries. If you have a population, if you have a census, if you want to find the population mean, you would use mu here as a notation for the population mean, where equals to the sum of all the x divided by the big N, where x is a data entry, right? And N is the population size. But when you have a sample, then you want to find the sample mean, then you would use x bar for the sample means, and you can calculate x bar using the formula, add all the entries together and divide it by small n, which is the sample size. Right? Now the median. What is a median? Median is a value that lies in the middle of your data when your data is ordered. Usually you order your data in the ascending order from the smallest value to the biggest, the largest value. So there's two scenarios here. When the data set has an odd number of entries, then your median is just the middle value of the order data set. For an example, if I have in my data sets, I have 5 values. Let's say they are 5, 3, 5, 6, 8, 7, and 10, right? So I have 5 values in my data sets. And the median of this data set, since this data set is already ordered in the ascending order, I just pick the middle value of this data set as my median. And the middle values is 6. All right. Now, when your data set has an even number of entries, the median is the average of the 2 middle values of the order data set. An example is I use the same data set, but I add another value, right? So I have 6 entries for this data. It's an even number of entries, and I want to find the median of this data. I would just take the average of the 2 middle values that I found it here. So 6 and 7 are the 2 middle values. And I take the average of 6 and 7, which give you 6.5. So the median here is 6. And the median in this data set is 6.5, which is the average of 6 and 7. All right. Now the mode. The mode is the data entry that occurs with the greatest frequency. So it's the data entries where you've seen the most frequently in your data set. A data set can have one mode or more than one mode, or it can be, it could have no mode. that means there's no entry is repeated. Sometimes we run into a data has two modes. This is called bimodal. All right, and usually people use mode for the measure as a measure of central tendency when we have data as qualitative data. So the mode is the most frequency category in your data set. And then another thing that we want to talk like briefly about is outliers. So outliers are the values that are far away from the most majority of the entries of the data set. Okay. The mean of a data set can be greatly affected by outliers, while the modes and the median would stay very neutral or would stay the same. Keep in mind, if you have outliers in your data set, then the mean will be scaled left or right depending on those outliers, whereas the median or the modes would stay pretty much the same with some few outliers. Let's look at an example. So if you look at this is the data sets, right? It's the data of number of nuclear plants in 10 countries. So I have a list of 10 values. Those are values that represents for the number of nuclear plants in 10 countries. And then if you look at this data set, it's already been ordered, which just makes it a little easier, right, to find the median. And the mean is just adding all these entries together divided by 10. And the medians would be the values, since we have 10 as a even numbers, right, of entries, then the median will be the average of the two middle values. So where are the two middle values? This should be these two values here. As you can see, there's 4 entries on the left of 9, and there's 4 entries on the left of 15. So 9 and 15 are the middle values. And the median, it should be the average of 9 and 15. So I would calculate this as 24 divided by 2 would be 12, right? And what is a mode? The mode is the most frequency entries. I can see that 4 is the only values that is repeated twice. So the mode is 4. And the mean is going to be just the sum of all the entries divided by 10. Let's go to this Google spreadsheet here. As you can see that on the first column, I have all the data entries. I enter all the data entries here on the first column, right? And then I can find the mean of this data is 23.8 is a mean of the data. And the median is 12, which is what we found, and the mode is also 4, right? So if we go back to the mean is 23.8. Using Google Spreadsheets, I can find these 3 values, the 3 measures of central tendency for this data set. And if you look at this here, I created a histogram for this data set, right? And you look at this histogram, you will see that a lot of data are most data entries are surrounding around this area, right? And you only have like probably one entry that is far away from the majority of the data set, right? Far away from the central tendency. So then you can see that, oh, if I look at this data set here, so 99 here could be one of the outliers, or it could be the only outliers because it's so far away from everyone else. And if you think if there is an outlier, then this outlier here will greatly affect the mean of the data set, right? And then you can see that the mean is 23.8, whereas the medians is only 12. So the mean is as most as twice as a median. I think it's because of this outlier. This outlier skewed this mean to the right of the data set. So when you have this data set and you see that there's an outlier, the mean is very large compared to the median. The measure of central tendency that we want to use to in order to figure out the central locations of the data sets, we should use a median for the measure of central tendency. The reason is the mean is not reflecting the actual mean of the data sets. It's that the mean is already being affected by the outlier, the entry of 99. So when you have a skewed data like this, right, you see that the data is kind of skewed to the right. Using the histogram, then using the mean is a good measure for the central of tendency. So in some cases, different data entries have different weights toward the mean of the whole data set. And when you have to find the mean of those data sets, it is called weighted mean. So a weighted mean is a mean of a data set whose entries have varying weights. And the weighted mean is given by, again, you use X bar for the weighted mean, right, for the mean, and it's given by the sum of the products of the entries and the weights, and divided by the sum of the weights, where W here is the weight of each entry X. Again, the weighted mean is calculated using this formula. You take the sum of the products of the entries and its weights and divided by the sum of all the weights. Let's look at an example. The next example, example number 6. When you have the scores in a class, you have different assignments: homework, quizzes, projects, and final exam. And for each assignment, you have the score for each assignment, and also you are given the percent of each assignment that is counted toward to the final grade. For an example, the homework in this class is worth 30% of the final grade. Quizzes, 35%, projects is 15%, and the final exam is 20%. Now, if you want to find the student's mean score, you have to use the weighted mean formula, because again, you have 4 different entries here, and each entry has different weights. So in order to find the mean, the student mean score or the final score, you can use this formula, which you want to take the product of each entry with its weight, and you sum all the products together. So first I take 85, I multiply to the weight, which is 30 in percentage, right? This is the products of one entry multiplied by its weight. Add the second entry, multiply to its weight as 95, multiply to its weight at 87, and multiply to its weight. And then you divide everything by the sum of the weights. So here are the weights. So the sum of the weight is 30 plus 35%, 15 plus 20. And your answer should be, so I calculated this data set using this Google spreadsheet here. Again, you have the assignment score for each assignment and the percentage of the final grade of each assignment. And this is how I calculate the final grade. So the final grade is 85.15. This is the final grade that I calculated in. All right, 85.15. 85.15 is the student's mean score or the student final grade in terms of percentage, 15%. All right. And also in some cases, when you do not have an access to the entire data set, but you have an access to frequency distributions of that data set, then how can you use that frequency distribution to find the mean, to estimate the mean of the data sets? Again, if you given a frequency distributions, you will be estimating the mean of the data sets. And how can you estimate the mean? You can use this formula here. So it's very similar to the weighted mean formula. It takes the sum of the products of each of x times f, right? Where x is the midpoint and f is the frequency of each class in your frequency distribution. Remember, in the frequency distribution, we have classes and we have frequencies, right? Now, x here is the midpoint of each class, and f is the frequency of the same class. So you multiply them together, and for each class, you multiply the midpoint and the frequencies. And for all the classes, you sum all the products of those products. And then you divide it by little n here. And little n is, again, is the sum of all the frequencies. Little n is the sum of all the frequencies, and the sum of all the frequencies is just the sample size. All right, and now we can talk about the very last sections of this last part of this sections is we can discuss about the shapes of the distributions. There are 4 different shapes that we'll be discussing in this class. The first shape is symmetric. A symmetric distributions is symmetric if you can draw a vertical line in the middle of the graph distributions, and that can split the graph into 2 halves that are approximately mirror images. So you draw a vertical line, and then the left side and the right side of that vertical line are just like the image of each other, mirror image of each other. So that's symmetric. And an example of symmetric distributions is here. As you can see that I can try to draw like a vertical line in the middle of the data set, right? And then you can see that the left half and the right half are like just like a mirror image of each other. And in symmetric distributions, the mean typically is the same as the median and is the same as the mode, right? Where all the where most of values fall in. So, and if you have a symmetric distributions, you can use either mean or median. Sometimes you can use the mode as the measure of central tendency for symmetric distributions. The second shape of the distributions is uniform. So uniform distribution is a distribution when all the entries or all the classes have equal or approximately equal frequencies. And a uniform distribution is just a special type of a symmetric distributions. So here's this one example of uniform distributions. As you can see that the frequencies for all the classes here are pretty much the same, right? They're not going to be exactly the same, but they're approximately equal to each other. And in uniform distribution, because it's just a special case of symmetric distributions, then you can say that the mean is the same as the median and is the same as the mode in uniform distributions. All right. Now go to the next distributions. We have scaled distributions. In scaled distribution, you have scale to the left and scale to the right. So scale to the left is the graph's tail extends to the left of the distributions, and scale to the right is when the graph's tail of the distribution extends to the right of the distributions. So this is an example of scale to the right distributions. As you can see that the tails of the graph extends to the right of the distributions here, right? So in skew, this is skew right distributions. And you want to observe the skew right distributions. When you have skew right distribution, that means most values fall onto the left of the distribution. So you observe more smaller values compared to the bigger values in the same distributions. If you're observing more smaller values, that means the mean of the distributions is, so in the skew right distributions, you're observing more smaller values. That means the mean, you will have see a lot of smaller values. So then the median of the distributions has to be less than the mean of the distributions if you have skew right distributions. So the median is less than the mean of the distributions here. Let me get another color. So you would say in this skew right, the median will be somewhere here, right? And then this is the median. And then you have the mean will be here. The mean will be greater than the median. All right, versus if you have a skew left distributions like this, skew left distributions, then you observe more larger values compared to smaller values. If you observe more larger values in the same data set, then the median will be greater than the mean. So I have the median around here. And the mean, because the smaller value skew the mean to the left, right? This is the mean here. What about the mode of the two scale distributions? In most of the cases, the mode is greater than the median, and also the mode is greater than the median here. So you have the mode. In this case, this is the mode. And usually keep in mind that if you have quantitative data set, you don't want to use the mode as your measure of tendency. So the mode. And in the scale right distributions, the mode is also should be greater than the mean and the median. All right. In skew distributions, the mean and the mode are affected by maybe outliers by the scales, by the skewness, but the mean are the measure that got affected mostly. All right, this lectures introduces the different measures of central tendency, how to calculate those measures, and how to calculate the weighted mean and the mean of group data or the mean of the frequency distributions. Also, we discuss the shapes of distributions. There are 4 main shapes that we will be discussing in this class: symmetric, uniform, skew right, and skew left. And how measure of central tendencies are reflected in each shapes of the distributions, which is presented here.